So we just talked about what a monomial is. That is a constant or a constant times some number of variables. And when we add several different monomials together, we get what's called a polynomial. The monomials, I mean, you could look at it, or generally how it's usually defined actually, is a polynomial with one term is defined as a monomial. So we kind of went about this in a little bit of a backwards way. We generally, in math, you would start by defining a polynomial as a generic, as something that's a bunch of constants times variables, and then you add those things together. A monomial is a polynomial with one term. A binomial is a polynomial with two terms, and a trinomial is a polynomial with three terms. So we don't really have specialized language for more terms than that. These are just ones that we see common enough, frequently enough that it's useful to have some nice language just to specify how many terms it has. Alright, to find the degree of a polynomial, to find the degree of a polynomial that has more than one term, I should say, you just take the highest degree term. So you take the degree of the highest degree term. So finding the degree of this polynomial, so we look at it in individual terms. This term right here is degree 3. This term right here is degree 2. This is degree 1. This is degree 0. So I'm doing the same thing for finding, basically the number of variables present in this term, the number of variables present in that term, and so on. 3 is the highest. So that means that this overall is degree 3. This one right here, we have a degree 0, a degree 1, and a degree 2. Since 2 is the highest, that's the one we get here. Alright, similarly with this example, finding the degree of this one, this is a degree 4, this is a degree 0, so the degree 4 wins. This really goes back to the idea I was talking about why we use degrees. If we start plugging large numbers into this polynomial would behave very similarly to something that's just a degree 4. This 24 here doesn't really contribute much of anything. If I'm doing a million to the 4th power, that million to the 4th power gets really, really, really large, and so large, in fact, that this 24 is negligible. So that's why we basically ignore that. The same thing would go with this polynomial up here. If I take a million squared compared to a million or compared to 3, these two terms are essentially negligible. And so that's why we only look at the highest degree term when we're talking about the degree of the polynomial. Because, again, the degree is talking about the end behavior, what happens when we start plugging large numbers into these polynomials. Alright, so when we have multiple different variables, again, we look at it term-wise. So here, this term here, we have 2 p's and a q, so this is a degree 3 term. This one right here, we have 3 p's and 2 q's, so there's a total of 5 variables there. 3 plus 2 is 5. So the highest degree here is degree 5. The highest degree term is degree 5, therefore that is the degree of the polynomial. This one right here, there's only a degree 0 term, so this is a degree 0 polynomial. Now, 0 is actually kind of in a class by itself. This one we would actually say it has no degree. We're kind of not defining what the degree of 0 is, because this could, I mean, you could think of it as 0 with no variables, but you could just as easily say it's okay, it has one variable, it's 0x, or it has two variables, 0x squared, or 0x to the 20th. So you could say it's degree 20. So because of this ambiguity and because of other reasons also, especially when we're talking about division, 0, the number 0, the polynomial 0, is in a class by itself, as, it tends to be.